I can approximate and interpret a function's average rate of change over a specified interval given the equation of a. All right, so what you need to know. When we aren't given a graph to look at, we can't immediately find the points that match the specified interval. So when we're given the equation of the exponential function, we can evaluate the function at each end of the specified interval, and that's going to generate the points that would have been on the graph. So if I'm given a function like this, f of x equals 3 to the x minus 1 plus 2, I'm not given the graph, but it tells me to find the average rate of change for the function between two specified points. I can then evaluate my function at those 2 points. So I can evaluate at f equals 2 and I can evaluate at f equals 5. And then once I have those values, I can apply my average rate of change formula, which is y2 minus y1 over x2 minus x1. So let's take a look at a problem and go through the entire process with that information. Okay, so in example 1, it says what is the average rate of change of the function f of x equals 5 times 3 to the x from x equals 2 to x equals 5. All right, now one thing to think about, if you think about whether or not my function is growth or decay, that's going to tell us whether or not we're going to have a positive change or a negative change. So since my b value, that one with the exponent, is greater than 1, I'm going to have growth in this example. Okay, so that's just a little check for us. So I need to start by evaluating my function at both of these points. So f of 2 would be 5 times 3 to the second. So when I evaluate this, in my calculator, you can use your calculator or you can use Desmos if you need to. We have 45 for our answer, and then when I evaluate at x equals 5, I have 5 times 3 to the 5th. And I end up with 1,215. Okay, so those are my two y values. If you think about this as a point, it's 2, 45, and this is 5, 12, 15. So now I can go ahead and apply my average rate of change formula to find my answer. So y2 is 1215 and y1 was 45. My x2 was 5 and my x1 was 2. So when I simplify this, 1215 minus 45 is 1,170. 5 minus 2 is 3. And when I divide, I end up with 390. So that is the average rate of change between those 2 points on my function. Again, it's positive because I have a growth example here because my base is greater than 1. So let's take a look. Now would be a great time for you to pause, try this on your own, and then come back to check to see if you got the answer right. So using that same information we talked about last time to check if it was growth or decay, notice this time the number I have with my variable exponent is 0.2, and that's between 0 and 1, so this indicates it's decay. So when I get my answer, I should have a negative answer because we are decreasing in my function. So again, I'm going to evaluate my function at 2 points. I'm going to evaluate at f of 0, so that's going to be 8 times 0.2 raised to the 0 power. Okay, and when I evaluate that, anything raised to the 0 power is just 1, so 8 times 1 is just 8. And then f of 5, I'm going to go ahead and evaluate this, so 0.2 raised to the 5th. And then we multiply that answer by 8, and I end up with 0.00256 as a decimal. Okay, so now when I go ahead, I'm actually going to do my work over here just for the sake of room. I don't have the same kind of room in my box. And you could use this as a fraction too if you did get a fractional answer in your calculator, but my calculator I'm using right now is my cell phone, so this guy just has decimals for me. So I'm just going to fill in my pieces. So I filled in my y2, okay, that's the second y that I found with, and then I put my first y that I found, I subtract those, and then my x values, I've got my x2 is 5, my x1 is 0, and then I can go ahead and I can subtract that. So that 0.00256 minus 8 is going to give me negative 7.99744, and that's going to be divided by 5. So when I do that in my calculator, I end up with negative 1.599, or negative 1.6 if you're rounding. So here you can see that we have a decay function because I got a negative answer. We're decreasing from 0.0 to 0.5. You can check out the Learning Target spreadsheet for additional resources, videos, and practice.